Hi, welcome to the Himsl YouTube Chemistry and Science Channel. As you can see, there's numbers all over the place. We can measure numbers, we can count numbers, all right? But there's certain rules we got to follow. Math and science, there's certain rules whether you take engineering, physics, chemistry, biology, all right? We got to know how to record the numbers properly. So I'm going to teach you now how to do it. Today's lesson is on significant figures and exact numbers. Alright, what are exact numbers? Exact numbers are numbers that you can count. For example, there's 12 eggs in a dozen, 24 students in the room, 100 pennies in a dollar, and probably most importantly for future calculations, many conversion factors are exact numbers. For example, there's 16 ounces in a pound and 2.54 centimeters in an inch. So keep that in mind later on in the next video when we do conversion problems. So anything you can physically count as an exact number. Alright, then we have significant figures, digits, significant numbers. It all means the same thing. So if your professor calls it significant figure, significant digit, it doesn't matter. It's all the same things. Significant figures are those numbers that are based on measurements and estimations. So you're using some kind of a measuring tool, and they have to follow certain rules in terms of recording the data. Alright, so in science there are many different measuring tools that we can use. There's different glassware, cylinders, volumetric flasks, beakers, etc. So there are a lot of things you can use to measure quantities. For example, if we're doing ruler measurements, let's take a look at these. Alright. Most rulers will have increments on them with numbers. So before you make any measurement, it's important to understand what the size of the increments are. So for example, if we're using the metric ruler, as shown on the slide, you see numbers, for example, between 5 and 6. Those are the centimeter units if you're using metrics. Okay, each line in between represents a millimeter. So if you count the number of lines between any of the numbers, there should be 10. So each little line is a millimeter. So that's 0.1 centimeters. Okay, so for example, if we're measuring the paper clip, like here, okay, we can measure with certainty that we know for sure it's between 1 and 2. Okay, so the last number we're estimating, so that looks like it's around 1.8. So we're going to record that number as 1.8 centimeters. Okay, now you can't record it any more accurately than that. You might argue I can read between the lines, but try taking a metric ruler and doing the measurement, you'll see that that's not the case. Alright, so the first number is the certain measurement. The second number in this example is the estimated number. And that's always subject to error. I'm sure if you gave this same paperclip to 100 students, they'd all come up with different values, but I'm sure most would come out with a reading of 1.8 centimeters. Okay, let's look at this example here. Alright, here we're measuring a pencil, so we know for sure the measurements between 7 and 8. Okay, so we're going to record that, and then the estimated number will be 0.5. Okay, because it looks like it's right at 0.5. So our measurement will be recorded as 7.5 centimeters. So when you're using metric rulers in the lab or in carpentry or whatever, just remember that you have the number for certain, but then you have the estimated digit, which is subject to human error. All right. If you need a little bit more accurate measurements, we use something called a vernier caliper. Okay, those are usually good to 2 decimal places. All right. So when you're measuring, using your measuring tools, just keep in mind that you can only measure to so many decimals, and that's it. Okay. So generally the rule of thumb is the more increments there are, the more numbers you'll have to record. So, okay. So in this example here, the estimated digit is 2. Alright, so here for practice. Alright, let's see if I gave you a question like this on a test. Alright. Well, what is the proper way to record the metric ruler at point F? Okay, so let's zoom in on that. Point F. Okay. Okay, so we know for sure it's going to be 8, between 8 and 9, so we're going to estimate it. So what do you think the answer is for that one? Right, take a minute. Okay. If you guessed 8.1, you were correct. Okay, so 8, between 8 and 9 is for sure. The 0.1 is the estimated digit, so the answer is 8.1 centimeters. Okay, let's move on to volume measurements. Okay. In chemistry and science in general, there's different tools we can use to measure volume. Most of the time you'll be using a graduated cylinder. Right? So depending on the size of the cylinder, you look at the size of the increments and then determine how large they are. So the smaller cylinders you might be able to read more accurately, the larger ones may go to the nearest whole number. So the one on the left is a 100 milliliter graduated cylinder. Okay. So if you look at the increments here, there's 30 and there's 40. Okay. So if you count, you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 lines between 30 and 40, which means that each line is worth 1 milliliter. Okay, so we can read for certainty. We usually read the bottom of the meniscus. All right. But many liquids form a curved shape, which we call a meniscus. All right, so we're going to estimate. So for sure we know it's between 38 and 39. Okay, so we're going to estimate that reading as 38.6 milliliters. Now, would it be wrong if somebody said 38.5? Probably not, or even 38.7. Okay, so always keep in mind the estimated digit's always subject to error. But so in this example, we'll record it as 38.6 milliliters. Okay. If you look at the measuring device on the right-hand side, that's called a burette. That's used a lot in titrations in chemistry. Okay. The burette is an interesting piece of glassware because you read it from the top down. So we usually fill liquid to the top, and then as we drain it, the liquid goes down. So you're recording basically from where you started to where you ended. Okay. So if you look at a burette, here's 38 and there's 39. All right, there's 10 lines between 38 and 39, so each line is 0.1 milliliter. All right, so if you look in this example here, let's zoom in a little bit. Okay, we know the reading is between 38.5 and 38.6. Okay, so we're going to estimate that as 38.56. So the estimated digit is the 6. Again, if you record it as 38.55 or 38.57, it's probably okay. Okay, so just to keep in mind that last digit's always subject to error. That's why it's important in science to reproduce data. All right, reproducibility is always important. So that's why it's important to do multiple measurements sometimes. Okay, so let's test your knowledge on the next slide. Okay. Alright, so let's say you were asked to do this reading here. So a student read the following 100 milliliter size graduated cylinder in the lab. What's the proper recorded number of this measurement? Okay, so take a minute, see if you can do that one. Alright, so what do you think? 30, so we know it's between 35 and 40, that's for sure. But if you look at the lines there, here's 35. Here's 36. So it's between 36 and 37. So what do you think? Okay. All right, so the answer is 36.5. Right? Because it's between 36 and 37. So we're estimating it's 36.5. So again, we can't read that any more accurately than 1 decimal place for that size cylinder. All right, let's go to mass measurements. Okay. All right. A lot of times in science we use what's called a triple beam balance. Many of you probably use digital balance, so when you use a digital balance, you record all the numbers. All right, don't round off. Whatever the display shows, that's what you record. But on a triple beam balance, all right, that's why it's called triple beam, because there's 3 beams. All right, 1, 2, 3. So you always read it from larger number to small. So we have 540, 2 point. Okay, what? So you have to estimate that. So let's zoom in on that one. So 542. Okay, there's a 542.4. Okay. Now again, you can't record that any more accurately than that, because for sure we know it's 500. For sure we know it's 40. For sure we know it's 42. So we're estimating that last digit. So 542.4 is the correct reading for that triple beam balance. Okay, so let's test your knowledge on the next slide. Okay, so let's say you were asked to do this one. This is actually one that I did in the lab of my class recently. So a student read the following mass using a triple beam balance. What is the proper recorded number for this measurement? Okay, so I'm going to zoom in a little bit on that one. All right, so what do you think? How would you record the data for that one? Okay, so we know for sure it's 200, you know for sure it's 70, and you know for sure it's 2. So the answer is C, 272.1. Okay, so the 1 is the estimated digit. Okay, well, let's move on. All right, so far you're doing pretty well in this. All right, so let's go to the next one. Okay, so the estimated digit is always the last digit in any measurement. So it could be, it could be 0 too. It doesn't matter. 0 is a number. This value is subject to error, but if you have good lab technique and can determine the value fairly accurately. Also note that the more increments you have, the more accurate it will be on a measuring device. All right, here's a little quiz for you. All right, so write if the following numbers are exact numbers or measured numbers. All right, so take a minute, write those down, and see what you get. Okay, let's check your answers. All right, 6 chickens is exact number, so you can count those. Centimeters is measured, so any number with a unit is a measured value. 176 pounds is measured. 100 cookies is exact. All right, 5,280 feet equals 1 mile. That's an exact number, okay? All conversion factors are exact numbers because they're equalities. All right, so there's exactly 5,280 feet in 1 mile. All right, let's move on to the next topic. All right, these are the rules for significant digits. All right, so I'm going to zoom in. So remember, when we do measurements, we have to follow certain rules for significant digits. Okay. All right, a number is a significant figure digit if it is a non-zero number. So for example, 4.5 has 2 significant digits. 122.35 meters has 5 significant digits. All right, so that rule is pretty easy. Rule B, a 0 between non-zero numbers is significant. Okay, so 205 meters has 3 significant digits. 5.082 has 4. Okay, because the zeros are in between. All right, now here it gets a little bit tricky. You got to pay attention to the decimal point. All right, so if there's a number that has a decimal or it doesn't, you got to pay attention to that. A 0 at the end of a decimal number. Okay, so any 0 to the right of non-zero numbers is significant. So always remember right, yes, left, no. Okay, so 50 with a decimal place, the 0's to the right of a non-zero number, so that's 0 significance, that's 2. 25.0, or there's a decimal, non-zeros to the left, that's 3 significant digits. Okay. And 16.00 has 4 significant digits. All right. All digits in a coefficient for scientific or exponential notation follow the same rules. All right, so don't pay attention so much to the times 10, 5 or the 10 negative 3 part, look at the number. All right, 4.0 has 2 significant digits because the zeros are to the right of its non-zero number. All right. Okay, number 2, rule 2, a 0 is not significant if it's at the beginning of a decimal number. We call those placeholders. Okay, so remember, left, no, right, yes. Okay, so 0.004 has 1 significant digit. 0.075 has 2. All right, now if there was a 0 to the right of 4, like say it was 0.0040, then it would have 2 significant digits. All right, so always remember, zeros to the left of non-zero numbers with a decimal are no, not significant. Zeros to the right of non-zero numbers are significant. All right. Now, if we have large numbers without decimals, then we don't have to worry about the rule. Okay, so 850,000 without a decimal is only 2 significant digits. If you put a decimal place, it would have how many? 6. Okay. Same thing with the next one, 1,250,000. Okay. That has. All right, so let's practice. All right, here's a quiz. All right, how many significant figures are in the following numbers? All right, so take a minute. Write those down. All right. Okay. All right, so how many significant digits are in those numbers? Okay, let's check your work. All right, so how many significant figures are in 28.65? If you said 4, you were correct, because that follows the first rule where all non-zero numbers are significant. All right, what about number 2? How many significant figures are in that number? Scott, if you said 5, you were correct. How about number 3? How many significant figures are in 3? 2. What about number 4? Right, so there's no decimal place, so what do you think the answer is? 1. Okay, and how many significant figures are in number 5? Right, that has 4. Okay, so remember, with a decimal point, zeros to the right of non-zero numbers are yes. All right. This one's in between, so that follows that one rule. All right, so that's 4 sig figs. How many sig figs does number 6 have? If you said 6, you were correct, and then the number 7 has 4. Okay, so those are the answers. All right, if you got those, you can do any problem. So, okay, let's move on to the next thing. All right, what are the numbers? Now, once in a while, when we do scientific measurements, we got to round data off. All right, so there's certain rules you got to follow in terms of rounding numbers. All right, so I call this rule number 1. All right, if the previous number is less than 5, then if the number is less than 5, then the previous number stays the same. Okay. Try to avoid using the term dropping the number, right? Because usually we don't drop anything. We just okay. So for example, round 47.4 centimeters to 2 significant digits. The answer is 47, because 4 is less than 5, so we drop the 4. Don't use the term round down. Okay, it's kind of a little, I think for me it's a little confusing to say round down. Just drop the 4. Okay, all right, try that one. All right, so that number has 4 significant figures. We're going to round it to 3 significant figures, so it would be, so 3 is less than 5, so we'll drop it. And it's going to be 56.2. So rule 1's pretty easy. All right. All right, let's go to rule number 2. If the number is 5 or greater than 5, then round the previous number up. Okay. All right, so 6 is higher than 5, so we rounded it to 48. Okay. All right, round 56.78 to 3 significant figures. If you said 56.8, you're correct, because 8 is higher than 5. All right. Now the problem is, for most common situation, most of the time in practical matters, if it's 5, we round it up. But in science and math, you got to follow a specific rule for number 5. So I call that the rule of 5. Okay, because if it's exactly 5, what do? You round up, or you round, or you drop it. Okay, so if the number is exactly 5, then round the previous number up if it's odd. All right, so I always remember odd up. If the previous number is even, then keep it the same. All right, I treat 0 as an even number in a lot of applications. All right, so here are some examples. All right, round the following to 2 significant figures. All right, so 47.5 is exact. All right, so we're going to round that to 48 because 7 is odd. All right, 46.5 goes to 46 because 6 is even. All right, now if there's any numbers after the 5, even if there's 10 decimals and a 1, then it's automatically higher than 5, so you round it up. So this rule only applies if the number is exactly 5. All right, so again here, even 5, 18. All right. Alright, try doing these problems. Alright, so take a minute and do those. All right. Okay. Alright. Okay, so this number here, 245.6, has 4 significant digits, so 6 is higher than 5, so you round it up to 246. Okay, that one's pretty easy. How about that one? Okay, 12.501 has 5 significant digits, but I want to round it to 3. Okay, now this is the rule 5 doesn't apply because there's a 1 after the 5. All right, so it automatically makes it higher than 5. Okay, so that's going to be 13. 20.814. All right, 4 is less than 5, so drop it. So that's 20.81 for 4 sig fig. All right, 109.5. Okay, odd up. Remember, odd up. So you're going to round it up to 110. Make sure you put a decimal point. Okay, because that means we have 3 sig figs. If you don't put the decimal, it's only 2 sig fig. All right, so make sure you put the decimal on that one. All right. How would you round 199.8 to 2 sig figs? All right. There's a different way we can handle that. So you round it to 200 because 8 is higher than 5. But if you just say 200, 200 only has 1 significant digit. This is kind of old school, but a lot of times people used to use a bar above the 0 to indicate it's significant. So if you see that, I put a little bar there. Okay. All right. So that would indicate that's significant. If you wanted 3 significant figures, just put a decimal point after the 200. All right. But another way you can handle this is what's using a method called scientific or exponential notation, which is on the next slide. All right, so let's do that. Okay, so what's scientific or exponential notation? All right, so this is a way to express very large or very small numbers. It doesn't necessarily have to be very large or very small, but you know. All right, so we usually write it like this. All right, so the proper format for scientific notation is to write the number. So it's usually single digit, decimal, and then any following numbers times 10 to the x power, which is how many places the decimals moved. All right. All right, so you always write the number as a single digit followed by a decimal. All right. All right. Okay, so single digit, decimal, the rest of the number. Okay. The exponent 10x is not times 10, but it just tells you how many decimal places were moved. So this means I moved the decimal point 5 times, or 5 places. All right, just to emphasize, the exponent does not mean times 10. All right, so don't put it in your calculator times 10. All right. So we'll see the examples. All right. So if you look on a lot of calculators, which will be, I'll have that in another video. All right. Check my other video on how to use the calculator and enter numbers in exponential notation. All right, we'll do that next. All right, so let's take that number there. Zoom in a little bit. All right. So the number 250,000, or we're going to do is put this number has 2 significant digits, so put an imaginary decimal count 1, 2, 3, 4, 5. All right, so 2.5 times 10 to the 5th would be the correct way to express that value. All right, so you just put an imaginary decimal, and you always keep the same significant figures in both numbers. All right, so don't change the significant figure. All right, so move it to 5 places to the left. All right. Positive exponents indicate numbers greater than 1. Okay, so it's going to be large numbers. Okay. All right, negative exponents indicate numbers less than 1. Okay, so here the decimals move to the right so many places. All right, so start here. The number has 2 significant digits. You're going to count 1, 2, 3, 4, 5. All right, so it's 2.5 times 10 to the 5th. All right, so scientific notation and calculator instructions I have in another video, but we can explain it here. So most, if not all, scientific calculators have the following keys. All right, so look on your calculator. Most of your cell phones don't have these, but they might. All right, so look for EE, EXP, or 10x key. All right. All right, so type in the calculator 2.5 times 10 to the 5th. All right, so depending which key you want to use. All right, so you can use this one, or that one. Okay, so it doesn't really matter. Okay, so if you want to use this key, that one, or that one. All right. So in your calculator, push the number 2.5. All right, hit EE, EXP, or the 10x key. Then hit 5, and then hit enter, and you should get your answer. It's 250,000. All right, so practice that. Okay, let's do another one. Let's type a negative exponent. All right. So on your calculator, push 7.2, hit EE, EXP, or 10x, doesn't matter. Use the negative or plus or minus key on your calculator. Don't use the minus key for subtraction. All right. So you should see some keys, minus or plus minus. Hit 3 and then hit enter. All right. You should get that as your answer. Now, keep in mind that some calculators may not give the ordinary number answers due to display limitations. So some do, some don't. Some leave it in the same format, but if you know the rules, you can figure it out, and you shouldn't have any problems. So, but these are 2 good ones to practice with, and you should be able to do all scientific notation calculations. All right. All right, so here's some rules. So some calculators may not give you the ordinary numbers due to the limitations in memory. Okay. All right. Don't record your data like this. This is not right. Okay, so a lot of calculators will show 7.2E5. All right, so don't write it like that because your teacher, professor will mark it wrong. All right. Rather, you put in the right format. So it's 7.2 times 10 to the 5th. Okay. All right, for negative exponents, do not use the subtraction key, but use the minus or plus minus key. All right. A couple people have asked me in the past, is it okay to record a number as, for example, 72 times 10 to the 4th? Okay. Now the number is not wrong, but it's not in the right format. Okay, so just to emphasize correct scientific notation: single digit, decimal, and then the numbers following. All right. So let's practice. All right. All right, so take these numbers and put them in the scientific notation. Pay attention to sig figs. All right. Okay, so let's do these. All right, so here's the answer. All right, so just has 2 sig figs, so that should have 2 sig figs. So put the decimal and go 1, 2, 3, 4, 5, 6. 1.5 times 10 to the 6th. All right. Again, you can go 1, 2, 3, 4, 5, which would be 15 times 10 to the 5th, which is not necessarily wrong, but it's not right either. It's not in the right format. So you always want single digit, decimal, following numbers. Okay. Let's try the next one. All right. So that's 1.25 times 10 to the 3rd. So count 1, 2, 3. All right, 1.25 times 10 to the 3rd. All right, now here we have a decimal, so that means that this number has 4 significant digits, so you want 4 significant digits here. So here's a decimal, go 1, 2, 3, okay? This number here has 3 sig fig, that one has 4 because of the decimal. So remember, with zeros to the right of non-zeros, with a decimal are significant. So right, yes, left, no. Which is like in this example here. So all numbers to the left of 3 are not significant. They're placeholders. But again, let's put it in scientific notation. Go 1, 2, 3, 4, 5, 6, 7. So 3 times 10 to the negative 7. Don't write 3.0 because then that'd be 2 sig figs. 3 only has 1 sig fig in this example. We're going to try that one. Go 1, 2, so 5.60 times 10 to the negative 2. All right, remember this 0 is significant, so zeros to the right of non-zero numbers with a decimal are significant. Left, no. So this is no, yes. Okay. Left, no, right, yes. 23 million would be nice to have in your bank account. Unfortunately, most of us don't have that, but maybe we will one day. Who knows? All right, so count. Go 1, 2, 3, 4, 5, 6, 7. 2.3 times 10 to the 7th. Okay. Okay, so if you can do these problems, you can do any scientific notation problem. Okay. Now let's work backwards. Okay. All right. So let's convert the numbers from scientific notation back to ordinary numbers. Now these you can put in your calculator for as a check. So just try it. All right. But see if you can do it manually. All right. Also. Okay. So take a minute. See if you can do those. Alright, so 1.6 times 10 to the 4th is 16,500. So in your calculator, type in 1.65 EE for enter. You should get 16,500. But we're all smart. We can figure it out. So here, go here and count 4. Go 1, 2, 3, 4. So 1, 2, 3, 4. Alright, don't put a decimal because that'd be 5 sig figs. We only have 3 sig fig here. So, okay. Alright, 8.70 times 10 to the negative 5th. So that means we're going to move the decimal 5 places in this direction. So you're going to go 1, 2, 3, 4, 5. Alright, so if you want to start here, you can just check 1, 2, 3, 4, 5. Alright, 3 sig fig, 3 sig fig. Alright. Alright, 1.2 times 10 to the 8th is 120 million. Again, you're going to count 8 places. 1, 2, 3, 4, 5, 6, 7, 8. Count 1, 2, 3, 4, 5, 6, 7, 8. Okay, I have another video on this, so you can check it out. I encourage you to look at it. All right, this is, people always say this is a trick question, but remember in chemistry and science there are no trick questions because there are certain rules, and if you know the rules, there are no trick questions. So get that out of your head now. Alright, so 5 times 10 to the 0 means you don't move the decimal at all, so it's just 5, right? Any number to 0 power is 1, right? Okay, let's try these. Alright, 5 times 10 to the 1st, you just move it over 1. Don't put a decimal, because 5 only has 1 significant digit. 1 significant digit. Alright, this is negative 2, so you're going to go here, 1, 2, alright? 1, 2. Don't forget to put a leading 0 in front of the decimal. I have a slide on that later on in this presentation. Alright, these are significant figures in math operations. Alright, so there's certain rules you follow for addition and subtraction. Alright, the final answer must be rounded off based on the number with the fewest decimal places. Alright, because that's the number we know with least certainty. So the final answer, even if you add up 100 numbers, the one that has the fewest decimals is what the final answer should be based on. So, alright, multiplication and division. Alright, the final answer must be rounded off based on the number with the fewest significant figures. Okay, so that's a different rule. Alright, so addition and subtraction is fewest decimals, multiplication, division, fewest significant figures. Now let's do some problems. Okay, so 24.56 plus 2.3. So without even doing the math, alright, that's an addition problem. See, the 0.3 is 1 decimal place, and the 5.6 is 2 decimals. So the final answer should only have 1 decimal. So what I encourage all students to do is, just do the math, write the calculator answer, and then round off the answer to the proper significant digits. Let's try that one. Alright, so this has 2 decimals, that has 3 decimals. The final answer should have 2 decimals. And don't forget to put the units, alright? Otherwise you get points taken off. Alright, so make sure you follow the sig fig rules plus put units. This doesn't have any units, so you don't have to worry about it. Alright, try that one. Okay. Alright, so that's, alright, this number has no decimal places, so the answer should have no decimal places. Alright, same rules apply for subtraction. Okay, so 1.08 minus 0.585, so 0.08 is 2 decimals. Alright, so again, write the unrounded answer and then round it off. So 9 is odd, 5 is exact, so you round it up 5.50 liters. Try this one. Alright, this has 3 decimals, that has 2, so the final answer should have 2. So again, do it on your calculator and then round it off at the end. Because if you get it wrong, at least you get partial credit for getting the right answer, hopefully. Alright, multiplying and dividing. Whereas base, final answer should have the fewest sig figs. Alright, so if you look at, this has 3 sig fig, that has 2. Unrounded, rounded correctly to 1.6, 2 sig fig. This is one of the problems with sig figs. You lose accuracy, but we got to follow the rules. All right. So anyway, that has 3 sig figs, 1 sig fig. Here's unrounded. This is correctly rounded to 0.01. Here's a division problem. All right. So point has 4 sig fig, 3 sig fig. Here's unrounded, calculator answer, rounded off properly to the correct number of sig figs. Okay. Here we got 4 sig fig, 2 sig fig, 3 sig fig. Unrounded, 2 sig fig, correct answer. That's because this only has 2 sig fig. Alright, so you might ask yourself the question at this point, what happens if I have mixtures of problems with adding and subtracting? Well, it follows the order of math operations. Alright, so if you have mixed problems, alright, you follow the rules. Please excuse my dear Aunt Sally. Math operations, which is on a later slide. Alright, scientific notation and sig figs follow the same rules as before. So answers with adding and subtracting goes by fewest decimals. Multiplying and dividing goes by the fewest sig figs. Alright, so let's do that one. Okay. Now you can put these in your calculator, which I encourage you to do. So do that. Make sure you put get the right answer down and write it down. Alright, but you first have to find out if you're rounding it off correctly. You want to make sure the exponents are the same. Okay. Now you can change either one. You can change either one. You could either change this to 1, or you can change that one to 3. So I always like picking the larger number and working with that because I find it easier. But it's up to you. But I always like using recommend using the larger number as a basis. All right, so 1.27 times 10 to the third is a larger number, so change to 4 times 10 to the first, move the decimal to the left 2 times. All right, so you get that. All right, so now that they're the same, now that you add them together. Okay, so this so addition follows the rules of fewest decimals, so they both have 2 decimals, so the final answer should have 2 decimals. So 1.3 times 10 to the third. Rules round based on fewest decimal. Here's addition and subtraction. All right, again, look at the 2 numbers. Okay, you can change either one, but I like taking the larger number. So 10 times 10 to the third. I would change 4 times 10 to the second to 4 times 10 to the third. All right. So move the decimal to the left 1 time. All right. So now when we subtracted the numbers, all right, so that's 2 decimals, that's only 1, so the final answer should only have 1 decimal place. You're going to write it like that. Again, do these on your calculator first, make sure you get the right number, and then use the rules to make sure you round it off properly. Alright. Alright, so for practice and checking, enter these in your calculator and round based on the rules previously discussed. Alright. Okay. Alright, multiplication, division, round, final answer based on the fewest sig figs. Alright. So these are easy. Just type these in your calculator. You know, there's certain rules that you can follow with the exponents. You can look that up in another video, but alright, just enter these in your calculator and write the answers down. So just look at the numbers that has 2 sig fig and that has 3, so the final answer should have 2 sig fig. Okay. Alright. So write down the answer and then put in the proper, being the numbers are in scientific notation, you leave it that way, so we'll round it off to 3.7 times 10 to the negative 2. Alright, because the 1.2 has 2 significant figures. Alright, so put these in your calculator. So just looking at that, how many sig figs should the answer have without even doing the math? Okay, if you said 2, you're correct, because this has 4 sig fig and that has 2 sig fig. So the answer should only have 2 sig fig. Alright, so that's the answer in your calculator. 4.3 times 10 to the negative 9. Alright. Alright. Now, once in a while in math and science, logarithms and natural logs are used a lot in math and science. So look for those keys on your calculator. Some scientific calculators always have a log and a natural log key. Alright. So logarithms have 2 parts called the characteristic and the mantissa. Alright. So enter the following for some put the number in first and hit log, and for others you hit the log button first and then the number and enter. So depending what kind of calculator you have, you got to do it in specific order. So if you have a calculator with you right now, all right, type in hit the log button and type in that number. I'm going to do it right now myself. 336.47. All right. So that's what the calculator shows. Alright, but it's not rounded off properly, so we got to follow the rules for a logarithm. Okay. Alright. So the number to the left of the decimal is called the characteristic, and the number to the right is called the mantissa. Alright. So the rule for significant figures is that the mantissa should have the same number of significant figures as the original number. Okay. Alright, so let's do that one. Okay, so if you hit the log of 3, alright, that's the answer, because 3 is 1 sig fig, so 0.5. Alright. If you type in log 3.0, 3.0 has 2 sig figs, so the mantissa has 2 sig figs, so that's 0.48. If you type that in, alright, 1.50 has 3 sig figs. Alright, so the mantissa, which is 824, has 3 sig figs. So you should express it that way. That one comes out negative. Alright, this should be a superscript. I gotta fix that. Alright, what if you take the inverse log? Alright, so a lot of times in a lot of scientific calculators, you gotta hit second or shift log to get the anti-log. Alright, so take a minute and see if you can do that. So it comes out as that is the answer. Alright, so in this answer here, the mantissa has 3 sig fig, so the answer should have 3 sig fig. Alright, so these are the order of operations which I talked about earlier. So follow the general math rule, PEMDAS. Please excuse my dear Aunt Sally. So do math operations from left to right in this order: parentheses, exponents, multiplication and division, and addition and subtraction. Alright, so let's try a couple of those. Alright, so for example, let's say you were asked to do a problem like this. Alright, so 2 plus 3 times 4. Alright, so what would be the answer? Alright, well, remember PEMDAS. Alright, so we do the multiplication first. So 3 times 4 is 12, plus 2 is 14. So multiply first, then add. Alright, if you have exponents, you do that first. So 5 squared is 25, plus 3 is 28. Okay, so just follow that order when you're doing math problems and science also. Okay. Right. So let's try that problem there with the exponents. All right, calculate the following based on PEMDAS. All right. So what I would do first is do this division. All right, this has 3 sig fig, that has 4. All right, and then do the minus. All right, so multiplication and division before addition and subtraction. Okay, so all right, if I take these two numbers, divide it, that's what I get as my answer, minus that. Okay. All right. And then we want to make sure we round it off properly. All right, so this number is bigger than that number, so I would want to maybe move that one over 1. All right, so this has 3 decimals, that has 3 decimals. All right, based on the fewest decimals, so the answer would be negative 1.596 times 10 to the negative 2. All right, always what's important in science, all right, math, leading zeros are important. Always record a leading zero in front of the decimal, okay? So if you're recording data, that's the right way to do it, and that's wrong, okay? So make sure you put a 0 in front of the decimal place, all right, because that emphasizes that there's a decimal present. All right, now the calculator is not as smart as you are because it doesn't know all the rules. So the calculator does not know the rules of leading zeros, so make sure you're careful when you're recording the display answers in it. I think some might have that feature, but most of the time they don't. So, all right, so don't be quick to jump and write the answer from the calculator. Make sure you're following the rules of significant figures and leading zeros. All right, so let's do a little pop quiz, all right, to test your knowledge. All right. All right, state the number of significant figures in those numbers. Okay. So what do you think? 4.5 has 2 significant digits. All right. How about the next one? It's 1. How many significant figures are in 625,000? Remember, there's no decimal place, so the answer is 3. And next one has 5, and the last one has 3. Okay, so this one emphasizes the rule. All right, decimal, zeros to the left, no. Okay, these are not significant. Zeros to the right, yes. So left, no. Right, yes. That's 3 significant figures. Let's do these problems here. All right. Okay, round the numbers to the specified number of significant digits. All right, so let's do some rounding practice here. 2 sig figures. What do you think? 7.448 has how many? 7.4 is the correct answer. Or how would you round 732,800 to 3 sig fig? 733,000. All right, now don't write 733 because that's not 733,000. You want to keep the same magnitude or size of the number. All right, I'm sure if you had that much in your bank and the bank only rounded it to 733, you'd probably be upset. So, all right, so the size of the numbers have to be the same. Okay, all right, this has 2 sig fig. All right, 2 is less than 5, so we got to drop it. All right, so it's 730,000. All right, how would you round the next one to 3 sig fig? Okay, well, 8 is higher than 5, so that would be 154. And then the last one would be 150 with no decimal point, right? Because if you put a decimal point, that would be 3 sig fig. All right, perform the math operations and round off answers to the correct number of significant digits. All right, so do these. All right, tell me what your answers are. So take a minute, do those. All right, without doing the math in the first one, all right, you don't have to do anything. All right, 4.5 has 2 significant, 2.856 has 4, so the answer should only have 2. All right, so do the calculation on the calculator. All right, we're going to round it to 13 because that's only 2 sig fig. All right, The next problem, again, all right, look at the numbers, all right. It has 4 significant, 3. These all have 2, so the final answer should only have 2. So do the math, do the multiplication and then divide. That's 19. All right. Here's an addition problem. 625 plus this. All right. So adding and subtracting goes by the fewest decimals. So it has 2 decimals, it has 3. So the final answer should only have 2 decimal places. All right. All right, same thing for the last one. 3 decimals, subtraction, 1 decimal. Final answer should only have 1 decimal place. Right, 165.4. Okay? So don't get the rules mixed up. Remember, adding, multiplying, dividing is the fewest sig figs. Adding and subtracting, it goes by the fewest decimals. Let's try a couple more with exponents. Let's try these. Zoom in a little bit. Alright, so this one here, alright, that number is -2, that's -4, alright, so that's bigger than that. So this one here I would convert to -2, so just move the decimal over 2 places, go 1, 2. Alright, and then add them together. Alright, so you should get that as your answer. Okay, let's do the next one. Alright, that's a division problem, so that has 3 sig figs and that has 2, so the final answer should only have 2 sig fig. 5.0 times 10 to the 8th. Alright, now here we have a mixed problem. Alright, so I would do this first, according to the rules, math operations, so multiplication, division before addition and subtraction. Alright, so do these. This is 3 sig fig, and then you're going to minus that. Alright, final answer should be 3.5 times 10 to the negative 8. And then finally, the last one. Alright, again, without doing the math, alright, how many sig figs should the final answer have? Alright, well, 1 decimal place. Alright, so when you do the math, round it off to 18.6. Okay, there are the answers again. Okay. Let's do this one here. Let's do some log problems. Alright, so take the log of 48.7. Alright, that has 3 sig figs. Alright. So the mantissa, which is the number to the right of the decimal, should have 3 sig figs. This is 3. This has 3. Okay. Right, if you're doing Avogadro's number, take the log of Avogadro's number. Alright, times 10 to the 23rd. Alright, this has 4 significant digits, so the mantissa should have 4. Alright. If we take the inverse log or the anti-log, alright, this is the mantissa has 3, the answer should have 3. Here the mantissa has 2, so the final answer should only have 2. So we express that as 2 times 10 to the second. Okay. Alright, so there you have it. Okay, congratulations. You're all now experts in exact numbers, measured numbers, and significant figures. Alright, so thanks for watching. And if you liked it, give me a like. If you look out for other instructional videos. And hope you all have a good day.